That VSEPR theory, you ask me, that is VSEPR theory, if you are talking uh, VSEPR theory.
Uh-huh. Yeah,
So,
could you?
hmm, there
I'll
are,
send you a few questions.
yeah, what?
I'll send you a few questions that I have problem with.
Okay, send me. You didn't say, you are going to send or already you sent?
I'm sending.
Okay. Hmm.
Okay, I'm just sending, sir.
Okay, no problem. This is what are a valence shell electron pair repulsion theory. Now, what is meaning of this?
Like how the bonds form.
Hmm.
Like the placement.
Hmm. This theory says the electron pair of valence cell gets repel. Valence cell gets repel.
Hmm.
That is what the.
So,
Hmm. I got the problem. I got the problem. Okay. Which molecule contain an incomplete octet electron? Right. The question number one is
mhm,
there. Incomplete octet they are asking.
mhm.
Incomplete octet. Incomplete octet. Okay. What are there? Option you have said here is NF3. This is what is the problem. This is the NF3. Second one is BF3.
Mhm.
Third one is BRF3. This tab writing pad I am having now, that is not either the laptop is problem or the writing tab. Okay, so Arav, you see NF3 is there, BF3 is there, BRF3 is there. This many molecules are there. Now,
Mhm.
how to find out? Firstly, go take the central atom. Always you try to take the central atom. So these are the central atom. Other more numbers are surrounding atom. So these are central atom, right?
Okay.
One bond
Yeah.
is equal to, or a one bond is equal to one bond. If you are defining one bond is equal to two electron, right?
Mhm.
So fluorine are forming three bond. A nitrogen, if you see, what is atomic number of nitrogen? That is seven. Seven means arrow. This is going to two comma five. Five are there, and three
Uh-huh.
bond are there. Three bond. So out of three bond means that is uh, three electron of nitrogen, three electron of fluorine. Means that is, if
Uh,
you see, that is three electron of fluorine also there. So total eight electron. It is becoming eight electron. So it cannot
yeah.
be our answer. Now BF3.
Oh.
Boron, if you see, our boron is five. And here you see
Mm.
Here configuration 2, 3. It is having 3 valence electron and 3 bond. Total electron in the valence shell it is going to be 6. And 6 electron is less than 8. This is what less than 8. Yes, yeah, no.
Yeah.
Less than 8. So that is incomplete octet. This is what is having incomplete octet. Can you understand? So this
Yeah.
is the first one answer is this is what is going to be incomplete octet. This is our required answer. So here this is the BF3 is the answer. BRF3 it is both are the having can you check sulfur? Sulfur is what is configuration? Sulfur is 16. 2 comma here is 8 comma 6. 6 valence electron and 2 bond. So 6 plus 2 it is going to be how much it is going to be 8 electron, right? Bromine, if you are saying that is they are the bromine and halogens, so that is 7 electron plus 3 electron, it is having 10 electron. So incomplete octet means less than 8 electron. So this is our required answer, BF3. Can you understand this one?
Yeah.
So option number B is correct, not C. So now let us see the, can I erase this one?
Yeah.
Okay. Now check out the next question. Question number 2. I am sharing the question number 2. Question number 2, if you see, they are saying tetrahedral. What is the molecular geometry and bond angle in the molecule of NO3 minus? Right. So if you see NO3 minus, here is NO3 minus. NO. This is not working at all. My laptop is problematic. NO3 minus. So Arav, if you see NO3 minus, so first of all we need to find out the hybridization state of the nitrogen. Okay. So I am solving this by shortcut method. Hybridization is equal to, what is the shortcut? 1 by 2. This is 1 by 2. It is going to B plus M. B plus M minus C plus A. Minus C plus A. And it is what it is going to do, that is, now it is hanged out.
So,
It is
there's no formal charge in our
formal charge, it is not the
syllabus.
formal charge. Arrow, because wait a moment, please, because this writing pad is not working, mine. So let me connect the tab. Please wait a moment only, not too much. It's totally not working. So we are hanging the problem. Here it is coming. Now see that is 1 by 2 number of valence electron. If you find how many valence electron is there in the nitrogen, can you tell me? How many valence electron will be there in the nitrogen?
5.
Not 5, not 5. 2 comma 5. Okay, okay, okay. So that is okay. Let me write the 5. How many monovalent are monovalent means the element forming single bond. Monovalent means that form single bond. How many are there? Oxygen
3.
form double bond arrow. So that is it is going to be 0. This is going to be 0. Minus we are having cation. There is no cation arrow. Positive charge.
Wait, sir, could you explain, sir,
Uh-huh.
can you explain the oxygen thing to me? The double bond?
Okay, wait. Just both are getting on in both. Both are getting on in both. Both are getting on in both. It will be. Is it? Is it audible? Audible now, Aro?
Yeah.
Okay. Let me check if I can. Yeah. I got. It is totally online classes are not that much feasible. Okay. So here, Aro, that is what I am telling you. V means what, Aro? Valence electron. This is valence electron. M means monovalent. This is going to be monovalent. Monovalent means what, Aro? Monovalence means if you are talking about single bond. Monovalent means single bond. That is what. Now, the C for cation. C is cation. Cation means number of positive charge. Cation means that is number of, this is going to be positive charge. That is what cation. Second one, A is there. A for anion. Anion means what? That is number of what is going to be negative charge. Number of negative charge. Very simple. Now, in this molecule, particular molecule, if you see, that is how many cation are there and how many anion are there, that we need to find out. Can you check out? So if you see the cation and anion here, so that is positive charge is 0 and negative charge is going to be 1. Negative charge is going to be 1. So it is going to be -1. Now let us try to solve 1 by
Wait,
2
sir,
in bracket 5.
can you tell me why does oxygen have a double bond?
Oxygen is having oxygen C 8 electron 2 comma 6. How many electron required to complete? 2 electron required to complete octet. Required to complete octet. So 2 electron and 2 electron required. So O and O. See 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These are there. So they are sharing 2 electron now. So now you can count out 2 to 4 to 6, 8 electron here and 8 electron here. So that is what 2 electrons here means double bond. So oxygen required 2 electron to complete the bond. That is why. Can you
But why
understand
does
this
it
one?
double bond with nitrogen, sir?
What are
You said it makes double bond with nitrogen. Why?
No. The formula is not saying double bond with the nitrogen. The formula is saying the atoms which form single bond or double bond. The oxygen form double bond. So that is monovalent. Hey? So here is the
double.
To complete the octet, oxygen required 2 electron. Na? Each oxygen required how many electron? 2 comma 6. It is having 6 electron. So 2 electron required. Na? So 2 electron means if 1 electron shared means single bond. 2 electron is shared means double bond.
Yeah, but sir, in NO3 minus the N and the O make a double bond. Why?
No, dear, that is the very different case. That is the nitrogen if you are talking about. NO3 minus. Na? Here is the one bond is there. Okay. And probably here is going to be another 2 places HNO3. Now, wait. This is not the structure here. We are not telling in this compound. Wait a moment. HNO3. Okay, HNOH, double bond O, coordinate bond O. Right. So it is how the bond in the NO3 minus is there. Okay, how the bond is there in the NO3 minus. You check out. Okay, this bond is something like that. Total bonds are 4. This type of. But here in the formula they are asking all the oxygen are making the double bonded. In this compound, formula is not for particular compound. This is the general formula. General formula is saying that is how many atoms of double bondage are there. Means monovalent atoms. Monovalent atoms. Okay, not the bond, single bond. Here they are saying single bonded atom. Single bonded atom. So oxygen, they are saying oxygen form the double bond. This compound is what? This is the resonating structure. Na? They all double bonded. All oxygen are double bonded. They all is going to involve in resonance. So everywhere it will be double bond. So we are oxygen cannot be considered the single bond. Always it form going to be double bond.
Okay, fine.
That you need to consider that if you are talking about hydrogen, hydrogen is going to form what kind of bond? Single bond. But it in case of oxygen, it will be the double bond. Nitrogen, triple bond, right? So
sir,
just
if it was
firstly apply this.
H2O,
Yes, Arrow?
if it was H2O, how many monovalent would there be?
The H2O means here two hydrogen are there, so two.
Okay.
Wait,
And
I am telling you. Firstly, let us complete this one, then I will tell you H2O. You are very much confused. Here, see, minus into minus, that is going to be plus. So this is going to be 1. So that is 1 by 2 plus 6, multiply by 6. So how much coming? 3. 3 means 1s orbital and 2p, sp2. sp2 orbital means trigonal planar. This is the trigonal planar. This structure is what is something trigonal planar. Now check in your here. Here checking in the, they are saying trigonal planar means 120 degree. Here this trigonal planar structure means one nitrogen is here, another nitrogen is here, and oxygen is here. So it is the trigonal planar, and angle is 120 degrees. So this is the what correct. A tetrahedral arrow, so they are saying what is the molecular geometry and bond angle of NO3 minus. So option number is B. Option number B.
yeah,
Which is correct answer? Can you tell me?
B.
Correct. B, na?
Uh-huh.
Okay, thank you very much. Now you are talking about the oxygen. Okay, let's see the oxygen. If you see the oxygen arrow, oxygen in water molecule, hybridization state of oxygen is what is? That is, it is the sp3. Okay, if you are talking about, this is going to be sp3. Can you explain why sp3?
Why is oxygen sp3?
That is what I am asking from you.
Oh, I was just asking.
Okay, no problem. H2O, na, H2O. See, if you are talking about oxygen, so I am considering the hybridization of oxygen. 1 by 2 B plus M minus C plus A. Okay, carefully. So what is 1 by 2? Number of valence electron in oxygen are
6.
number of valence electron in oxygen.
6.
Thank you very much. 6. Monovalent, 2 hydrogen. Hydrogen form single bond or double bond?
Single.
What type of bond is formed by hydrogen?
Single bond.
Single. So how many are there? 2. Is there any positive charge in this molecule? Positive charge, negative charge?
No.
No. So that is 1 by 2 plus it is, that is how much? 8. 1 by 2 plus 8, multiply, not the plus, sorry. So it is going to 4. So this is going to be sp3. This is what is the tetrahedral. Tetrahedral. But tetrahedral is geometry. Shape you are talking about, so that will be bent shape. This is the shape. Two electron pair will be here. So H2O is what? Something 104.5 degree. This is bent shape. But here hybridization is what? sp3.
So what's sp3?
Can you understand this one? sp3.
What is that, sir?
But question, where is the question? Question is not there, na?
No, sir, I'm
Question is
asking
not there.
what is sp3?
One s orbital and 3p orbital combined. Hybridization I taught you now.
Yeah, sir, but my concepts weren't clear.
One s orbital and 3p orbital combined. 3p orbital combined. 1s orbital and 3p orbital combined.
And how do you
So
find
that is
the
what making the that is the detail explanation. In the shortcut you cannot understand. No.
yeah.
Okay. See, if you are talking about H2O, so oxygen is 8, 1s2, 2s2, 2p6. No, 2p, not 6. It is going to be 2p4. So here is 2p. It is going to be 4. No, this is going to be 2p4. Now, what we are going to do here, so 2p4 are there. So what we can do in this case, you just see how many vacant orbitals are there and how many paired orbitals are there, that you need to see. So here, if you are making this configuration, so this is 1 and 2. These places, if you are making, this is going to be 1, 2, 3, and 4. How many unpaired electron? For making two bond, no, O needs to form two bond. O needs to form how many bond? Form two bond. Two bond. So two unpaired electron required. Here, how many unpaired electron required? Two, no, two bonds. So two unpaired electron required. No, two unpaired electron required. It is having two unpaired electron here. But here, what is they are going to do? They are hybridizing. No? So what is 1s orbital and 3p orbital? They are going to hybridize. So if it is going to hybridize like that, four new orbital will form. So oxygen, one hybrid orbital, another hybrid orbital, another hybrid, and this are. So here two hydrogen atom are sharing one electron, one electron of hydrogen, one electron of oxygen. Here is lone pair electrons are there. That is why if you are making the same oxygen, here is lone pair, here is lone pair. This is the bond and this is the bond. And 104 degree, no 5 minutes, no something 104.5 degree. This is what is the concept. Now, what else you are asking? Because last time I was teaching, I think it was not clear to you. Now ask me, what is the problem now? Please.
1s2, 2s2,
Four
2p.
orbitals are there, na? So four orbital, two contain lone pair. Two are the unpaired electron or bond pair. Unpaired electrons are known as bond pair.
Sir, what about the 1s?
Is it okay?
Oh, 1s2, 2s2. Okay, so then becomes 1 and 2, and then
This is the electronic
P4.
configuration now.
Yeah,
Hmm.
understood.
This is hmm. Now go for the next question, Arav. Next question. What is the next questions, if I will
Sir,
say?
can I just ask you one more question?
Please. Hmm.
Okay, so
Hmm.
why is it 109.5 and 120 both trigonal planar? And how do you know which one?
No, that is different. If it is the see bend shape, this angle you are not going to measure. It is the experimental data. This is
But how would I know
this is
which one to
what
click?
you are
Because I
writing.
put 195, but it's
That you need to memorize.
okay.
That we need to memorize. There is no alternative for this one.
Okay.
For water, how many bond angle is there? That is the this you memorize. Tetrahedral shape, how much is there? That we need to memorize. There is no alternative for this one. Bond angle is need to memorize.
Okay.
Bond angle is supposed to memorize.
Okay, fine. Okay, so we can go next.
What is the next question? Here we are having the next question. Your connection, internet connection is unstable. Okay, check predicted electron domain geometry around the carbon and both nitrogen atom NH2, this is applying VSEPR theory. Okay, so this compound looking like good questions here. So let us see. This is question number. I don't know what is the question number you have shared. Mm-hmm. Harav, can you guess the answers?
Can I guess the answer?
Hello.
Hello?
Question number. This is, what are the predicted electron domain geometry around the carbon and both nitrogen atoms in urea? In urea molecule, they are asking what is the predicted geometry? What geometry you are predicting?
Yeah. So I put A.
Hmm.
But
You
it's
are
wrong.
saying A, but how you are saying A? That reason required na.
Yeah.
Hmm. Yes, Harav. What reason will you give?
Mm,
Okay, no problem. Arav, see the urea structure is there. NH2. See, Arav, these are not the difficult. We need to clear the doubt. That's it only. Okay. NH2, CO, NH2 is there, Arav. This is right. Now, if you are making the structure, Arav, C double bond O will be there. Here is N. Uh, Suppose I am making NH2, and here is also I am making NH2. Right. Now, to know this structure, we should know the what is hybridization. Okay, what is the hybridization? Nitrogen are, if you are talking about nitrogen, okay, valence electron, hybridization we are going to calculate our, right, hybridization. So how to calculate the hybridization here? Let's see. So HY hybridization is equal to 1 by 2 V plus M minus C plus A. C plus A. There are 1 by 2. Number of valence electron in the nitrogen 5. Monovalent, how many are there? 3 are there, I think. Carbon is not monovalent. So total
so
3.
wouldn't
It
it be
is going
4?
to be SP. What are
Wouldn't it be 4 because there are two hydrogen on each side?
that is. No. For a particular nitrogen, you have to separately calculate. For each nitrogen, separate calculation is there. 538. So what will be there, Arav? That is 4. It is going to sp3. Now you check out the nitrogen, but here they are saying what are the predicted electron domain geometry around the carbon and both atom in the urea applying VSEPR theory. So okay. That can be answered easily, not a problem. So here is, this is another nitrogen, you see, if you are talking about this nitrogen. So what is going to happen? So hybridization is going to be again sp3 only. Hybridization is sp3 only. Okay. So but they are asking hybridize, what is the predicted electron domain electron geometry around the carbon and both the urea. Okay. So here also it will be the sp3 only, sp3. Carbon, if you are calculating carbon, if I will go for the carbon, so 1 by 2, B is the 4 electron, monovalent is 2, no cation plus anion. So 4 to 6, 1 by 2 into 6, it is going to be 3. So it is sp3. So around the first things you can do here, first things, that is in the Peru yellow color. Okay. So here, so this is going to be trigonal planar. Carbon is going to be trigonal planar. Okay. So A number. And after trigonal planar, this one geometry they are asking na. So that is sp3 means what? What is that? Is tetrahedral. Tetrahedral. This is going to be tetrahedral. Now you check out the geometry they are asking na, geometry. So trigonal planar and tetrahedral. Option number B.
Yeah, sir, but even in carbon, there's sp3. So how do you know the difference?
Arav, again, please repeat your question, please.
Sir, um, even carbon is sp3. So why is that trigonal planar and not tetrahedral?
No, carbon is not sp3, Arav. sp2. Carbon is sp2. Carbon is sp2. Please clear it. Why sp2, Arav? See, oxygen is double bond, na? Oxygen is double bond. So we are not considering. How many single bond are there? 1 and 2. So valence electron carbon is having, that is 2, 4. 4 valence electron is there. This is the valence electron. And Arav, monovalent, how many are there? 2 single bond, na? So 4 plus 2, that is 6. 1 by 2 into 6, that is equal, coming 3. 3 means 1 s orbital and 2 p orbital.
Okay.
Are you be able to understand, Arav?
Yeah.
100% clear, or should I explain again?
Understood, but sir, could you
Clear.
tell me? Yeah, could you just tell me what would be the orbitals for trigonal pyramidal?
Trigonal pyramidal orbital you are asking.
Yeah.
This is the, see, 3 orbital, na? 3 orbital. Trigonal pyramidal you are saying, or trigonal planar?
Planar
This is
is
the planar.
sp2. Planar is sp2. Pyramidal would be what?
Pyramidal, okay, see the, okay, see the NH3 structure, Arav, NH3. So this is going to sp3. This is sp3 because lone pair is there, na? So 3 bond pair, 1 lone pair. Total pair is 4. 4 pair means tetrahedral. So here is the one is going here. Another is, this is hydrogen, hydrogen, and hydrogen. So geometry is tetrahedral. Geometry is going to be tetrahedral. This is the geometry. This is going to be geometry. But if you are talking about shape, Arav, shape is the trigonal pyramidal. You see? So one triangle it is making here, triangle, and one pyramid is on the top. Can you understand this one?
Okay.
This is the trigonal pyramidal. Trigonal pyramidal. Because that is downside, it is the trigonal, and above there is the pyramid is there. So this is. So can we move another question, Arav?
Yeah.
Okay. Let me check another question where you have sent me. Sorry, taking time. This is also over. Which molecule is non-polar? Okay. Which molecule is non-polar? That okay, that we need to understand. Arav, polar, if you talk about polar and non-polar. Okay. So if I will say polar, Arav, polar means, the concept saying polar means, Arav, that is bond between two different atoms. Bond between two different atoms. Two different atoms. That is called polar. Non-polar. Okay. Between same atom. That is what is. Second one, if symmetrical molecule. Symmetrical. Yeah, plane symmetrical means plane of symmetry. If plane of symmetry is there, so that is non-polar. It is going to be non-polar. Between same atom, that is going to be non-polar. Oh, I wrote wrongly. Sorry. Wait. In case of non-symmetrical, no. Sorry. See, here is polar talking about now. No plane of symmetry. No plane of symmetry. Plane of symmetry should not be there. No plane of symmetry. And here is plane of symmetry. This should be plane of symmetry. Now in these two things we have to apply. Okay, OF2. OF2. Ab OF2, you see, this is tetrahedral because oxygen is having two lone pair electron and two bond pair electron. So what are the, you see bent shape. OF2 is bent shape. So if it is bent shape, it is the, what is? This is the two vector are going where? Towards the fluorine, because fluorine is more electronegative. And dipole moment, okay, dipole moment is the polar quantity, that is vector. So these two vector will be added, it will give the this side. Okay, this is. So that is the, it is polar. It is polar. Can you say this is polar?
Yeah.
Okay, now go for the second one. If I will go for the second one, B number NH3, NH3. So nitrogen is having lone pair electron. This is hydrogen, hydrogen, and hydrogen. Where that is bond will attracted around, they are the negative charge, electronegative. So this is polar is going here. This is going electron going there. This is electron going there. This electron is going here. So all are going to added. All are. So that is what is the, that is mu is equal to not equal to 0. So it is
Okay.
also going to be polar, right?
Because
Now
nitrogen is more
BF3.
electronegative than hydrogen, right?
Hydrogen is less electronegativity now. So nitrogen is attracting electrons. So R vector are going towards the what? Nitrogen side. So that is polar. They will be positive charge. They all will be negative here. So polar. BF3. BF3 is what? sp3 sp2 hybrid. sp2 hybrid means boron. Here is fluorine. This is fluorine, and this side fluorine. Now this is the what the planar structure. Yes, yeah, no? So that is the planar symmetry is there now, plane symmetry. So that will be the non-polar. Why? Because one vector is going this side, another vector is going this side, one vector is going to this side. And vector quantities are what? Additive and subtractive. They will cancel out. Each vector will be cancel out. This will cancel this will cancel. That is mu is equal to, it is going to be 0. Mu is equal to 0. It means what are, it is going to be non-polar. Can you understand this one? Non-polar. So our required answer will be
angle,
BF3.
okay. So the angles will be 120
Angle is
degrees, right?
120 degree. 120.
Okay.
Yes.
Yeah.
SO2
So
is the bend shape. SO2 is going to be bend shape.
okay. So may I go to the bathroom 1 minute?
So bend shape. What are?
Can I go to the toilet 1 minute?
Please. Aro, again you rejoin. It is getting to off. You rejoin, no?
Okay,
You
I'll come
rejoin,
back from the
please.
bathroom and
Can you rejoin? Okay. I'm waiting. No problem.